Welcome to this video about 13 design patterns every developer should know. If you're a developer, you've probably heard about design patterns. No, they are not the colorful shapes on your grandma's knitting, but they are just as important. Design patterns are reusable solutions to common problems in software design. They are like cheat codes for developers. Instead of reinventing the wheel every time you encounter a problem, you can use design patterns to make your code more efficient, flexible, and easier to maintain. Let's start with the strategy pattern. Don't worry, we're not talking about some grand battle plan here. This is a coding pattern that will make your life easier. Imagine you're a knight and you're about to face a dragon. Do you charge with your sword or do you stand back and use your bow and arrow? Well, with the strategy pattern you don't have to choose, you can use both. In coding terms, the strategy pattern lets you define a bunch of different strategies, like attacking with a sword or attacking with a bow, and then switch between them at runtime. It's like having a whole arsenal of weapons at your disposal. Let's take a look at some code to see how it works. In this example, we define two different attack strategies, sword attack and bow attack, both of which implement the attack strategy interface. We also have a knight class, which has a reference to an attack strategy object. At runtime, we can switch between the different attack strategies by calling the setAttackStrategy method on the knight object. This allows the knight to dynamically change their attack strategy depending on the situation they are facing. So whether you're facing a dragon or just a particularly tricky coding problem, the strategy pattern is here to help. Alright, let's talk about the observer pattern. It's like having your own personal YouTube channel, but instead of viewers, you have a bunch of objects. In coding terms, the observer pattern lets you define a one-to-many dependency between objects, so that when one object changes, all of the objects that are subscribed to it are notified automatically. It's like having your own army of followers, but for your code. Let's take a look at some code to see how it works. In this example, we define an observer interface and a subscriber class that implements it. We also have a channel class that has a list of subscribers and methods for subscribing, unsubscribing, and uploading new content. When new content is uploaded to the channel, the notify subscribers method is called, which notifies all of the subscribers of the new content by calling their update method. So if you want to keep your objects informed and up to date, the observer pattern is a way to go. The decorator pattern. It's like wrapping a gift in multiple layers of wrapping paper and ribbons. Just like how you can add different layers of decoration to a gift to make it more personalized, you can use the decorator pattern to add extra functionality and behavior to your objects without modifying their original code. In programming terms, the decorator pattern lets you to attach additional behaviors to an object at runtime by wrapping it in decorator object. This means you can add new functionality to an object without having to create a new subclass or modifying its existing code. Let's take a look at some code and see how it works. In this example, we define a gift interface and a simple gift class that implements it. We also have an abstract gift decorator class that extends the gift interface and takes a gift object as a parameter in its constructor. We then define two concrete gift decorator classes, wrapped gift and ribbon gift, that added extra functionality to a gift object by wrapping it with shiny paper and colorful ribbon respectively. Finally, we demonstrate how to use the decorator pattern to add multiple layers of decoration to a gift by creating a simple gift object and wrapping it with wrapped gift and ribbon gift. So if you want to add some extra functionality to your object in a flexible and dynamic way, the decorator pattern is the perfect gift for you. Factory pattern is like font factory that delivers different models of fonts based on your needs and preferences. Just like font factories can produce a variety of fonts with different features and specifications, the factory pattern lets you create objects with different implementations and behaviors without having to know all the details of their creation. In programming terms, the factory pattern is a creational pattern that provides an interface for creating objects in a superclass but allows subclasses to alter the type of the object that will be created. This means you can write code that works with a generic interface, but at runtime you can decide which implementation of the interface to use. Let's take a look at some code and see how it works. In this example, we define a phone interface and 3 concrete classes that implement it: Basic Phone, Android Phone, and iPhone. We also define a type to represent the different phones that we can create. We then define a phone factory class with a static createPhone method that takes a phone type parameter and returns an instance of the corresponding phone. This allows us to create different types of phones by simply calling the createPhone method with the desired phone type. So if you want to create objects with different implementations and behaviors in a flexible and easy way, the factory pattern might be a good solution. Singleton pattern is like Spider-Man, the one and only web slinger in the multiverse. Just like how there's only one true Spider-Man in each universe, the Singleton pattern ensures that there's only one instance of a class in the entire program. In programming terms, the Singleton pattern is a creational pattern that restricts the instantiation of a class to a single object. This means that no matter how many times you try to create an instance of a class, you'll always get the same object. Let's take a look at some code and see how it works. In this example, we define a Spider-Man class with a private static instance variable that holds the one and only instance of the class. We also define a private constructor to prevent external instantiation of the class. We then define a static getInstance method that returns the instance of the class, creating it if it doesn't already exist. This ensures that no matter how many times we call the getInstance method, we always get the same object. So just like how Spider-Man is the only one original web slinger in his universe, the Singleton pattern ensures that there's only one instance of the class in the entire program. Knowing command pattern is like having your own personal army of stormtroopers to do your bidding. Just like how Darth Vader commands his loyal stormtroopers to carry out his orders, the command pattern allows you to encapsulate a request as an object and delegate it to different objects to perform various actions. In programming terms, the command pattern is a behavioral pattern that allows you to encapsulate a request as an object, thereby allowing you to parameterize client with different request, queue, or lock requests and support undoable operations. Let's take a look at some code and see how it works. In this example, we define a command interface that defines an execute method which will be implemented by concrete command classes. We then defined 2 concrete command classes, jump command and attack command, which implement the command interface and provide their own implementation of the execute method. We also define a command invoker class which maintains a list of command objects and provides method to add new commands and execute all commands in the list. So just how Darth Vader commands his stormtroopers to carry out his orders, the command pattern allows you to encapsulate a request as an object and delegate it to different objects to perform various actions. Use it wisely, young Padawan. The adapter pattern is like having USB-C to Lightning adapter to charge your phone with your USB-C cable. Just like how the adapter helps you connect 2 devices that have different interfaces, the adapter pattern allows you to convert the interface of a class into another interface that the client expects. In programming terms, the adapter pattern is a structural pattern that allows you to convert the interface of a class into another interface that the client expects. This allows classes with incompatible interfaces to work together. Let's take a look at some code to see how it works. In this example, we define 2 interfaces, Lightning phone and USB phone, that represent 2 different types of devices with different charging connectors. We then define 2 classes that implement these interfaces, iPhone device and Android device, which provide their own implementation of charge with Lightning and charge with USB methods. We also define a Lightning to USB adapter class, which takes a Lightning phone object in its constructor and provides an implementation of charge with USB method by using the charge with Lightning method of the Lightning phone object via adapter. So just like how a USB-C to Lightning adapter helps you to connect your iPhone with your USB-C charger, the adapter pattern allows you to convert the interface of a class into another interface that the client expects. Use it wisely and don't forget your adapter. Have you ever watched Iron Man and wondered how Tony Stark can do all those amazing things with just a few commands to Jarvis? Well, it's all thanks to the Facade pattern. In programming terms, the Facade pattern is a structural pattern that provides a simplified interface to a complex system of classes. It hides the complexity of the system and provides a single point of entry for the client to interact with. Let's take a look at some code and see how it works. In this example, we have three classes: Jarvis, Iron Man Suit, and Tony Stark. Iron Man Suit uses Jarvis as a dependency to perform various functions such as booting up, attacking, and defending. Tony Stark uses Iron Man Suit to suit up, attack, and defend. The Facade pattern comes into play when Tony Stark uses the Iron Man Suit to interact with Jarvis. Tony Stark doesn't need to know all the nitty-gritty details of how Jarvis and Iron Man Suit works together. Instead, he just uses the simple and straightforward interface provided by the Iron Man Suit to accomplish his goals. So just like how Tony Stark can perform amazing feats with just a few voice commands to Jarvis, the Facade pattern provides a simplified interface to a complex system of classes. Use it to simplify your own code battles. Have you ever made your own tweaks while preparing some meals from a recipe and thought to yourself, wow, this is so easy, I feel like a pro chief? Well, that's the template method pattern at work. In programming terms, the template method pattern is a behavioral pattern that defines the skeleton of an algorithm in a superclass but lets subclasses to override specific steps of the algorithm without changing its structure. Let's take a look at some code and see how it works. In this example, we have two classes, spaghetti recipe and stir-fry recipe, that inherit from abstract recipe class. The recipe class defines the general steps that any recipe should follow, but leaves the specific implementation details to the subclasses. The spaghetti recipe subclass implements the specific steps for making spaghetti, while the stir-fry recipe subclass implements the specific steps for making stir-fry. Both subclasses share the same basic algorithm, but they can override specific steps as needed. Just like how following a recipe can make you feel like a pro chief, the template method pattern can make you feel like a pro developer. Use it to simplify your own programming recipes. Have you ever had to loop through a collection of items and perform some operation on each one? Of course you have. It's a common problem in programming. But what happens when the collection is too large to fit in memory? Or when you don't want to expose the underlying data structure to the client code? This is where the Iterator pattern comes in. The Iterator pattern provides a way to access elements of a collection without exposing its underlying representation. Instead of exposing the collection itself, you create an Iterator object that knows how to traverse the collection and return its element one by one. Many programming languages provide support for Iterator pattern in their collections. For example, in TypeScript, you can use the iterable and iterator interfaces to implement iterators for your own collections. Let's take a look at some code and see how it works. In this example, my collection implements the iterable interface and provides an iterator. The iterator object has a next method that returns the next element of the collection until there are no more elements left. The for of loop then uses the iterator to loop through each element of the collection and log its value to the console. Have you ever played a game where you form a team with your friends and then your team join forces with other teams to create a massive army? Well, that's exactly what the composite pattern is all about. In software development, the composite pattern allows you to represent hierarchical structures as a tree of objects, where each object can be either a leaf node, or a composite node, just like how players can form subgroups that can form bigger groups in the game. In the composite pattern, leaf nodes represent individual objects and composite nodes represent the groups of objects. Let's take a look at some code and see how it works. In this example, we have player class that represents an individual team member with a certain power level. We also have a team class, which is a composite of team members and has a name as well as ability to add and remove team members. Both player and team implement the team member interface, which defines a getPower method that returns the total power of member or team. We then create some players and teams and add the players to the teams. Finally, we create a composite team, which is a composite of other teams, and we can see that its power is the sum of powers of the teams it contains. Imagine you're Bruce Banner, the mild-mannered scientist who transforms into the Hulk when he gets angry. One moment you're sitting calmly in your lab, and the next moment you're smashing things and wreaking havoc. That's the perfect example of the state pattern. The state pattern allows an object to change its behavior based on its internal state. In the case of Bruce Banner, his behavior changes drastically when he transforms into the Hulk. Let's take a look at some code and see how it works. In this example, Bruce Banner class has an internal state represented by the Hulk state interface. The calm state and angry state classes implement the Hulk state interface and represent the different states of Bruce Banner. When the smash method is called on the Bruce Banner object, it delegates the call to the appropriate state object. When the state changes, for example when Bruce Banner gets angry and transforms into the Hulk, setState method is called to update the internal state of the Bruce Banner object. Have you ever heard the saying, fake it till you make it? Well, the proxy pattern is all about that. It's like having a stand-in do your work for you while you sit back and relax. It's the ultimate laziness hack. In programming terms, a proxy is a class that acts as a substitute for another class. It allows you to control the access to the object and add extra functionality without changing the original code. Let's take a look at some code and see how it works. In this example, the RealImage class represents an actual image object, while the ImageProxy class acts as a stand-in for the RealImage. When an instance of ImageProxy is created, it doesn't immediately load the image from the disk. Instead, it waits until the display method is called and only then creates an instance of RealImage and calls its display method. This way, the loading of image is deferred until it's actually needed, which can be useful in situations where loading image is time-consuming operation. Congratulations! You have now learned about 13 powerful design patterns. You like the Avengers of software development, armed with the tools to build anything you can imagine. But remember, with great power comes great responsibility. Don't go crazy and try to use every pattern for every problem. You don't want to end up like Thanos, snapping your fingers and turning your codebase into the dust. So go forth, use your newfound knowledge wisely and don't forget to have fun. And if you're interested in learning more about these patterns and how to use them effectively, be sure to check the book Head First Design Patterns by Eric Freeman and Elizabeth Robson. With their clear explanations and fun examples, you'll be a design pattern master in no time. Excelsior!